This is our last video on day one, summation notation. It's pretty fun stuff, I'm going to tell you right now, okay? So, summation notation is when we use the Greek letter sigma in capital, and you probably have seen it with, say, in possibly Excel. You do a lot with Excel, okay? It means that you're going to sum up or add up all of the terms. And then this is where you begin. The bottom is where you begin. The top is where you end. And you're going to go by integers. Integers means, you guys call them whole numbers. It just means that you go up like 1, 2, 3, 0 to 1, 2, 3, 4, 5, 6, something of that nature. So here, you'll notice, we say we let n equals 0 up to 5 of n. Okay. So that means I'm going to plug 0 in for n. If I plug 0 in for n, look what I get out. I get out 0. Then I'm going to go up to 1. If I plug 1 in for n, I get out 1. Go up to 2. Plug 2 in for n, I get 2. Plug 3 in for n, I get 3. 4 in for n, I get 4. And I go all the way to 5 because that's what's on top. 5. And then so the summation notation means I'm going to add them all up. Notice I have the plus signs in between them all. So 0 plus 1 plus 2 plus 3 plus 4 plus 5 is 15. That's called summation notation. And again, we're going from n equals 0 up to n equals 5 using integers. So, what happens then if we let f of n equals n squared? Okay, well, if that's true, then we're going to take 0, plug it in. We get 0 squared, which is 0. We would get 1 squared, which is 1. 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, and 5 squared, which is 25. Right there, and that equals 55. So the bottom part is known as the lower bound. The upper part is known as the upper bound. It's not always going to be 0, and it's not always going to be 5. These are just an example. So take a look here at number 9, okay? So look, the lower bound is 1. The upper bound is 7. So I start with 1, and I plug it in. 2 times 1 is 2. 2 plus 3 is 5. 2 plus 3 is 5. So I get 5 for my first term, plus. Then I go up to 2. 2 times 2 is 4. 4 plus 3 is 7. Then I go up to 3. 2 times 3 is 6. 6 plus 3 is 9. Hey, wait a minute. I see what this is doing. This is going up by 2's every time. Oh, yeah. Look, I have repetitive multiplication, which is, repetitive addition of 2, which is multiplication. So I'm going to go ahead, and I have 5 plus 7 plus 9 plus 11 plus 13. The question is, where do I stop? Well, I stop at the 7th term. So this is 1, 2, 3, 4, 5. You could put, we know you're going to get 6 and 7, so you're going to have 2 more. Or you could have put a 7 in. 2 times 7 is 14. 14 plus 3 is 17. And you could have just followed this pattern until you got up to 17. Then you got to add them all up. 5 plus 7 is 12. 12 plus 9 is 21. 21 plus 11 is 32. 32 plus 13 is 45. 45 plus 15 is 60. 60 plus 17 is 77. So I get 77. Hold on a second, bud. Hold on a second. So now if I look at number 10, my lower bound is 2. My upper bound is 6. So I'm going to start out by putting 2 squared. Well, 2 squared is 4. Plus, then I put in a 3. 2 cubed is 8. Plus, I put in a 4. 2 to the 4th is 16. Oh, wait a minute. I see what's going on here. I am multiplying by 2 every time. Oh, yeah, because this is an exponent, which is showing repetitive multiplication. Again, how do you know where to stop? Well, you want to get to, so this would have been 2. This would have been 3, 4, 5. We got one more because that'll take us up to 6 where we end. So we get 2 to the 6th, which is 64. And then I add these all up. 4 plus 8 is 12. 12 plus 16 is 28. 28 plus 32 is 60. 60 plus 64 is 204. 204, sorry. 104. 104. Silly me, silly me. 104, guys. Not 204. Hello. 104. 124. Oh my gosh. Hello, mathematical skills coming back at me. 124. I apologize. 124. Okay, so for each given sum, write the summation notation. Okay, so we're going to have summation notation. This here is the explicit equation. This is the explicit equation. So we need to figure out the explicit equation for this. So 5 to 10, well, I first think it's arithmetic. And 10 to 15 is add 5. Yep, it is arithmetic, so I'm adding 5 every time. So the way I like to do it then is repetitive addition is multiplication, so 5 times n. If I put in a 1, I should get this first term of 5. So if I plug a 1 in here, 5 times 1 is 5. Sure enough, I got it. So it's just 5n. This is going to go from n equals 1. How many terms are there? 2, 3, 4, 5, 6, all the way up to the 6th. There it is. And if you think about it, if you plug a 6 in, 5 times 6 is 30. You're good to go. Let's look at this one here. 5 to 10. Well, you might first think it's adding 5. 10 to 20, though, is adding 10. So immediately you know it's not arithmetic. So how else can I get from 5 to 10? Well, you can multiply by 2. 10 to 20 is multiplying by 2. 20 to 40. Okay, this is geometric. So summation notation. So this is going to be the initial or the first number, 5, times my common ratio, or thing I'm multiplying by every time, which is 2, to the n minus 1. I'm going to start out with n equals 1. So I do 1, 2, 3, 4, 5, all the way up to 5. Okay, folks, that's it, man. This is easy stuff. You got summation notation, and you got this. You can do it. All right, good luck. We'll see ya. Bye.